All right, we're going. Okay, questions from the homework last night, my friends. What can I help you with? Yeah.
Can you go over question 23?
On 6 or 7?
7.
7? You got it. Number 23, it looks like 14, that's 23. A squared, b to the third, minus 7, a b to the fourth, plus 21, a to the third, b to the second. Okay, so again, I'll write it all the way out. Some of you might start seeing the patterns, which is fine, but I'll write it out for you to decipher. So I know that 14 is 2 times 7. I have 3 terms. So 2 times 7, and then a squared is a times a. B to the third is b times b times b. My second term, minus 7 doesn't break down, times a times b times b times b times b. Oops, I have to go down a little bit. And then this one, 21 is the same thing as 3 times 7. Excellent. 1, 2, 3, 4, and then, okay. That third A just had a hard time. Okay, my friends, I do have 3 terms still. They're just all broken up. Agree? So, it looks like I can, a 7, agree? What else? A single A and 2 B's? Yeah, because there's 1, 2 there. And I'll take care of those 2. And then those 2. Okay, so I just went to each of the terms, just highlighted it. The things that are highlighted are what's going to come out front. So I have 7 that's going to be out front. I have a single A. I have a B and a B. So that's B squared. So what do I have left here? I have a 2, an A, and a B. Okay, so I have 2AB minus, I have BB, which is B squared. And then plus, because that plus sign, 3AA, or 3A squared. That's exactly how we do that problem. Just break it completely down. What else did you see, my friends, on either of those sheets? Yeah.
Question 17.
Same page?
No.
Oh, other page? Question 17. That's on 6, right?
Yeah.
Can't even remember what I'm doing these days. Okay, so this is question 17 on the first page. So they just used V rather than X, which is okay. And when we do this, we're just going to multiply them together. So I get 36 V squared plus 6V minus 6V, and minus 1. Because these are the same binomial, but one sign different, that means the middle terms cancel. And there's my answer. Anything else you'd like to see on any of the stuff we worked on, friends? Okay, so let's get our notes out. I give you that packet, which is good for today. If you forgot it, grab a sheet or 2 of this paper up here, and you can just write down on that. Yeah. I gave it Tuesday, right? Okay. I'll go grab it. I'll be right back. I'll leave this here because it'll disconnect. Remind me I left it there, okay, Dan? Yeah. Does anyone else need one? Because I might have a couple extra. 2? Like what? Oh yeah, I might need one too. Yep. Yep. Did I forget anybody? Yeah. Who's back there? Dan, you were supposed to tell me. Man, you had one job. I'm just kidding. All right. So we are going to continue, bless you, more of our ways of looking at factoring. Okay, so this is called factor by grouping, in which we've already kind of done the first step for you. Okay? So what we're going to do is we're going to take a look at this, and we have two terms right there and there. Okay, yes, they could be multiplied together. Usually this will come to you where it's already multiplied out, and you'll see this in a few more examples where it would have been put all together. But what you do is you take a look at the two, and you're like, hey, you know what? I have this, and I have this. They're the exact same. So I'm going to pull the whole binomial out front, and I'm left with this and this. And I'm just going to put this in a second equation. Now, if you got this for an answer on this problem, right at this moment right now, I think you're totally right. But I want to show you something real quick. Okay. So let's talk about a perfect square. A perfect square of a number would be like 1 or 4 or 9 or 16, because 1 times 1 is 1, or 2 times 2 is 4, or 3 times 3 is 9, or 4 times 4 is 16, so on and so forth. So, my friends, with what I just said, if like 9 is a perfect square, that's the same thing as 3 times 3. Is x squared a perfect square? Because it's x times x. Yeah. So this is a little bonus footage. So this, I'm going to put that this is a perfect square. Perfect square. And 4 is also a perfect square. So this is a precursor to something we're going to see a little bit later. Okay? Now, x squared minus 4 is going to be the same thing as x plus 2 and x minus 2. Okay? Remember, if I double distribute here, if I go x squared minus 2x plus 2x minus 4, my middle terms drop out. That leaves me x squared minus 4. So this is a preview. So like right now, this answer for this example is right here. We're done. But I just wanted to give you a little preview of something that's coming. We're going to start factoring perfect square, or difference of two squares is what that's called. Difference meaning subtraction, two squares. We have two perfect squares that are being separated by a subtraction sign. So we're going to eventually get to that. But as of right now, x plus 3 and x squared minus 4, both sets in parentheses, would be my answer. May I move on? Okay, so we're going to do the exact same thing we did before. I have two terms. Agree? Okay. This and this are the same, so I'm going to bring that out front. X minus 2 comes out front. What do I have left? I have an x and I have a plus 3. So I just put that in the other set of parentheses. And here's my answer. That's it. Okay. Take a breath. Exhale. Okay. Let's take a look at the next problem. I have 1, 2, 3, 4 terms. Agreed? Remember, a term is separated by a subtraction or an addition sign. So does that fall into suit saying we have 4 terms? Okay? Being we have 4 terms, I'm going to look at my first 2 terms, which are those. And I know that 10 and 10 are the same number. I don't even have to factor them. Yeah.
Where are we?
Because we did that
Where-
one.
We did. Wait, which one did we do?
Oh, no. Yeah, Oh, you did that one.
Which one were you looking? Where? What did I start here?
Yeah, I think you did.
Hang on, I'll go back.
And then,
Common factor. Well, I did that one. I did that one, right?
yeah, I don't think we have that one.
Huh. I don't know why I didn't copy. Shoot. Do what? Oh, flip the page over.
Okay.
Nope. Is that it? There it is. There it is. It's at the top of that page, the top of that next page. Thanks, Josh. Sorry about that. I didn't know why that didn't show up. I guess it's too big. All right. So do we all feel good so far? Everyone's caught up again? 4 terms. So I don't even have to factor 10 to break it down to 2 and 5 because I see that I have a 10 and a 10. So that's got to be a common factor. Agree? So I'm going to factor that 10 out, and then I'm left with A minus B. So I haven't factored out anything else yet, but that's what I'm going to get to right now. I like it. I like your thinking. Yep. So I'm going to do this. I'm going to highlight this whole thing. Now, this has a little tiny trick to it. Yes. If you have a subtraction sign here, this is going to be part of our factor. Okay? So, being I have the 12 and the 12, I'm going to factor out negative 12. And then if I factor a negative 12, if I factor the negative 12, this right here, I have this. Now, careful. I'm factoring, good. I'm factoring a negative 12 out. So this sign has to change. So it's going to be A minus B. Okay, now let's think about this real quick. I'm going to erase this in a sec. If I go negative 12 times A, do I get negative 12A? And if I go negative 12 times negative B, do I get positive 12B? Okay, so that's kind of sometimes a trick. So I didn't mean to throw that curveball in. For one, you had to find that problem. And two, I don't know. Who knows? All right, so now, does this problem here look similar to this one here? Yeah, I have here and here are the same. So I'm going to factor A minus B out. And I'm left with 10 minus 12. And my friends, I bet you could do the math. What is 10 subtract 12? Negative 2. So I have negative 2, and then A minus B. Okay, because that came together. That gave me that. Oh, I shouldn't have thrown such a curveball at you on that first problem. Maybe we can clear it up on the next page. Hopefully we can find the next example. Being I'm playing hide and seek on my notes with y'all. Sorry about that. So that was a tougher one. I don't know if we're going to see that quite yet on the homework, but that was a tougher one. Let's see if we can clean it up. Can I move forward? Josh, you good? Yeah. All right. Oh, okay. This one looks a little nicer, my friends. Is this the next one on our notes? We found that one? Okay, good. All right. So I'm going to look at my first 2 terms. So x to the third is the same thing as x, x, x. Agree? And x to the second is x, x. So how many x's do I have in common just in the green?
5.
In common. In common. In common. I have 2. I have this one, this one, this one, this one. Okay? So I'm going to pull xx out. Xx is x squared. Agreed? And then I have this x left, so I'm going to bring that down. The plus. If everything factors out, what's a placeholder?
1.
1. Okay, we're done with the first part for now. Okay, we're done with the first part. On the second one, I'm going to look at these. What do I have in common?
3.
3. If I factor a 3 out of 3x, I'm left with x
And then
plus,
one.
and then a 1 has to be as a placeholder. Okay, so my friends, take a look here. Take a look here. Are those the same? Okay, we're going to factor this out. I have x plus 1 and x squared plus 3. And that's what it is. Woo, baby. Take a breath. Seem okay? So kind of a little couple more steps, yes? But I think it's doable. So our next problem, we have 4 terms. So I'm going to look at these first 2. So without writing everything out, does anyone want to take a shot at what we could factor out of both those underlined in green? Go ahead.
You can factor out 2x.
So you mean like x squared?
Yeah, 2x. You like put all the x's back out.
Okay. So let's take a look.
Also, I'm sorry.
You're good.
Or you do factor all the x's, and 2 times 2, and 6 times 2, and 2 times 2 times 3.
So I have those 2 in common. Is that what you're telling me?
Yeah.
And I have those 2 in common. So if I factor out 2xx, that's the same thing as 4x squared. Agreed? Friends, what do I have left?
3
3
and an x.
and an x. So this x comes here, plus comes here, 3 comes here. Okay? We're done with that for a moment. We're now going to go to the other equation. Oh, remember I said if that term is negative, we got to make sure we factor a negative out. So that's negative 3x minus 3 times 3. So I can factor a 3 out of both of those, and it's a negative 3. If I factor a negative out, the signs have to change. So this is no longer be a negative x, it's going to be a positive x. This is no longer going to be a negative 3, it's going to be a good. Friends, between the purplish color and the red color, does it look like x plus 3 is the same thing? So I get x plus 3.
And 4x squared
Minus
minus
3. Yeah. Once I factor that out, I have to put it back together, the other one together with those 2 terms. So this is my factored answer. Okay, pause for a minute. Ask a question if you have a question. If something didn't show up right, so there's a little bit different method right now. Agree? The nice thing is this is what we're going to be practicing. Now notice, friends, I'm not adding anything together because I don't have like terms up there. A like term is the same letter. That letter has to have the same exponent for you to add or subtract it. So there's not any like terms yet. Friends, may I move forward? Okay. Now we come across a small problem. Does it appear this problem has like terms? I have 3x and x. Are those like terms? So theoretically, I could have added those together to get 4x. But I'm not going to. I have it broken into 4 terms. We had said if we have 4 terms, we're going to look at our first 2 terms first. Friends, what does it look like that what I underlined has in common? 3 and an x? Agree? So if I factor a 3x out of 3x squared, what's left? X, and great, because 3x completely factored out, I have to have a placeholder. Oh boy, oh boy. Look at this. Look at this. Okay, thinking caps. This is the easiest question to answer, but the hardest one to think about. What can I factor out of x plus 1? There's only one number. 1! Yes. I can factor a 1 out. Now, if I factor a 1 out, that doesn't change a thing. Ooh, there's a little trick. Those are the same. Agree? What do I have left? Done. Yeah.
So, if you just put down the x plus 1 equals 2, and then you do 3x plus 1, or you do x plus 1.
Yeah.
Yeah, you did x plus 1, and then for the 3x, since it was just by itself, you just put in 1 equals 1. So, you do it like that.
Yeah, you can. You totally can. The main thing is, please don't forget this 1, because that has to go there. That's the main thing to think about on that problem. If there's nothing to factor out, then you have to factor a 1 out, because 1 factors out of everything. It's kind of a special property of 1. Okay, so thought process is starting to go a little bit, right? Starting to think, whoa, wait a minute. We just created maybe an extra wrinkle in our minds, our brains. I don't know if we really created another wrinkle or not. They had once said long ago that intelligence, you can tell how intelligent a person is by when you take a look at their brain. If they have more folds, they're more intelligent. But they have now proven that is not true. So people used to call people, oh, that person's a smooth brain. Well, it's because they don't have enough wrinkles in their brain. It has nothing to do with intelligence. There's your anatomy lesson for the day. And I say, what? May I move on? Okay, got that? Oh, cool. Last 2 things to work on. Okay, let's go real slow. So let's just look there. 3, anything else? 3 and an x. Now let me just stop there. I'm just going to write that down. Do you feel comfortable between those 2 terms? There's a 3 and an x in common between the 2. You feel comfortable with that? If I factor a 3x out of 3x squared, what's left? A single x. And then a what?
5.
Why is it a 5? I think you're right, but why?
Because you can factor out the 15x to x times 3 times 5, and I factored out the 3 and the other 5 left over.
My friend, I couldn't have said it any better myself. Great job. All right. Hey, this one, because I have that term right in the center, has a subtraction. What do you guarantee I'm going to factor out? A negative. What do I have in common between these 2? 2. If I factor negative 2 out of negative 2x, what do I have left? Nope.
Yeah, positive x.
Positive x. If I factor a negative 2 out of negative 10,
Positive 5.
positive 5. Let's stop. Do we agree? If you don't see it right away, take negative 2 and distribute it over x plus 5. So negative 2 times x is negative 2x. Negative 2 times positive 5 is negative 10.
Don't you do the usual both of them?
Yep, so I have x plus 5 and x plus 5.
Plus 5 x 3x minus 2.
That's it. Whatever I have left over goes in the other set of parentheses. That's all it is. So I want you to note something on this problem. My friends, do you agree where I put those 2 little zigzags, whatever you want to call them, little stars, asterisks, whatever? Do you agree that those are like terms? And everything about our learning in life says let's put together like terms. Unless there's 4 terms and we don't. We group them together. We look at the first 2, then we look at the second 2, and then we move on. Okay? Last problem for the morning. My friends, x to the third minus 2x squared. What does it appear I might have in common between the two? I have an x. Is there anything more? I'll write this out. I have x, 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 and I have 2x, x. So how many x's do you think?
2.
2, so x squared. If I factor an x squared out of x to the third, what do I have left?
X.
Minus 2. Good. Good, good, good. Uh-oh. If the very center is a subtraction, I'm going to have a subtraction here. Agreed? So signs are going to change. Agree? -4. I like it.
Minus x plus 2.
Is it minus x?
No, I don't know why I said minus. X plus 2.
Close?
Minus 2.
Minus 2. Agree? Ooh, this is a little extra. All right, friends. Those are the same. As far as this homework goes, I would totally accept that answer. But look back at your very, very, very first slide that we did. What was the very first problem we did on these notes? Yeah. So that x squared minus 4 is a special one. It's going to break up to x plus 2 and x minus 2. So theoretically, I would totally accept this answer right here. The next version of this problem is having x minus 2, because I have that, and then I have x plus 2. Oh, that should have been a minus 2. That's a minus, and an x minus 2. So we actually have two x minus 2s. So this is a later answer that we will start getting to. As of right now, if you can get to here, I think you have accomplished your goals. Okay, let's take a look. What do we have here? Schoology. PEF number 8. Do the odds, but look at the due date, my friends. It's due on Wednesday. We do not have class on Monday. No online class on Monday. No school at all on Tuesday, but we have an online or the remote day on Wednesday. Is that okay? Feel comfortable with that? All right. Any questions for me, my friends? All right, I'm going to stop recording my video.